New video. Okay, so this is the video tutorial for the contest Codeforces Global Round 25. This is the very first problem, dual trigger. The problem says that there are n lamps numbered from 1 to n lined in a row, initially turned off, and we can perform the following operations any number of time. That is, choose any. Sorry, just 1 minute. Let me close the setting here. Yeah. Somebody started drawing on the screen here. Okay, so the problem says that we have n lamps numbered from 1 to n. In one operation, we can choose two non-adjacent lamps that are currently turned off and turn them on, and we have to determine whether it is possible to reach the configuration S, where Si equal to 1 denotes that the ith lamp is turned on and the other one says that the ith lamp is turned off. And they have here mentioned that by non-adjacent lamps, they mean that like all the lamps such as I and I plus 1 for all I from 1 to n minus 1, they are considered to be adjacent. And the lamps n and 1 are not considered to be adjacent for n greater than 2. So let me just open it here as well. I think that the problem should be pretty clear already, that we have n lamps numbered from 1 to n. So these are like lamp 1, 2, 3, 4, 5, 6, 7. And we have been given a string, let us say string S. In the string S, if on the third position it has a 1, it means that the third lamp is on, else it is off. So this is how they have been telling a configuration for the lamps through a string. Initially, we have all the lamps as set off, and what we can do is choose two lamps, two non-adjacent lamps actually. Like we cannot choose this and this lamp together. We can choose any two non-adjacent lamps. Both of these should be turned off initially, and we can then set them as turned on. We can basically turn them on. And what we have to tell is whether it is possible to reach this kind of a configuration, whatever configuration which has been given to us in the problem, we have to tell whether it is possible or not. Okay, so is the problem statement clear? Guys, please tell me yes or no in the chat, whether it is clear or not. Okay, so some people have said yes, nobody has said no. I believe that it should be clear then. So the very first observation which I had right away while reading the problem is, since we can choose two non-adjacent lamps together, notice on this part that we have to choose two lamps even if this part was not there. Still, we would have to choose two lamps. There is one additional constraint here, uh, which should be turned off initially and we will have to turn them on. So the thing is, since we have to choose two lamps which are initially off and turn them on. So in case if in the given string, let us say there are 7 ones, there are 7 lamps which are turned on. Can I say that this configuration would never be reachable? Because the thing is, initially I have zero turned on lamps. There are no lamps which are turned on initially. Then in one operation, I would have turned on 2 lamps. Then after that, I would have turned on 4 lamps, then 6 lamps, then 8 lamps, and so on. The number of lamps which are turned on would always be even. It can never be odd because I am converting the lamps from off to on in pairs of two lamps, right? So at the very least, I can just count the number of ones in the given string and check if this thing is odd. If the number of ones is odd, then my answer is definitely no. Now the question is, what if the number of ones are even? Is it possible to reach to that state or not? By the way, in case if this observation was not really that obvious for you by while reading the problem, you could have got the idea by looking at the example set. Even if you have tried to look at this example and would have tried to figure out if it is like not sorry, not for this, but for this example, if you had tried to think of a way of reaching this configuration, you would have realized that since I can turn out two lamps at a time together, I won't be able to have five lamps on at any time. So you got the idea for this as well, that why is it failing? But yeah, one more thing. We have one more constraint that the lamps should be non-adjacent. Right. The lamps should be non-adjacent. The spelling is incorrect here. Adjacent. Yeah, adjacent. Okay. So the lamps should be non-adjacent. So you might have got uh, an intuition that what if I'm having multiple ones together? Would it be possible to turn on lamps in such a way that I get this kind of a configuration? And they actually have this kind of an example as well. So if you would have looked at it and would have tried to figure this out, maybe they have given it as well. Uh, no, they have not explained how to get to this configuration in the example test cases, but you could have got to the idea that I will turn on this lamp with this lamp. Maybe let me just write it down. Let us say if we have this kind of a configuration which we want to reach, and initially, obviously, we have zeros. Then in that case, what we can do is pick up this, like you cannot pick up the ones which are coming up together, but you can pick up some different one along with it. So maybe pick up this one along with, sorry, some one which is coming up far away, then convert them in a way. And you see that here it is failing, but obviously there are ways of figuring it out. What you could have done is uh, pick up this guy along with this guy. So you will have got it converted and then convert these. Basically, what I want to say is if you would have tried to think about this kind of a case, you would have realized that if there are more than four ones in the given array, like if there are more than four ones, then you would always be able to light up the lamps. And you would have noticed that if I'm having some ones coming up in a distance, that kind of configuration is also possible because I can just turn on these lamps together as these are not adjacent. And like right now, I'm not actually showing you to get to this intuition. I'm telling you what you could have tried and you would have noticed it if you genuinely tried this out. You would have come up to the conclusion that, like, you would have actually noticed that if I'm having a lot of ones, there is always a way of making all of them one in one way or the other, but it would always be possible. The only case where I fail to make up all the ones together is what if I'm having some ones together in a row. Basically, I might have a lot of zeros or maybe some zeros, like any number of zeros. If I'm having two ones together and that's it, I'm not having any other one in the array. In that case, I won't be able to pick up this one or this one with any other lamp and turn it on. Basically, this kind of a case will give me answer as no. Right. We would always fail in this kind of a case. Uh, And for all the other ones, if you genuinely tried, you should have realized that it would always be possible in one way or the other. So at the end, you could have come up to the conclusion that if the number of ones is odd, then the answer is no. And if in the string there are only two number of ones and both of them are coming together and both are coming together, then also the answer is no. This is what you could have come up with. And in all the other cases, which means that the number of ones is even and um, it is not having this kind of a case where it is impossible. In all the other cases, it would always be possible. If once is zero, you don't really have to do anything. In case if once is two, but they are not coming up together, in that case as well, you can just do it in one operation. And if once is greater than equal to 4, then you would always be able to just combine those once in one way or the other. So you will get the answer as yes. So these are the only three things you would have to do. Check whether the number of ones is odd or not. Check whether the number of ones is two and both are coming up together. If this is coming, this condition satisfies, then also your answer is no. Otherwise, your answer is yes. Okay, so shall we move on to the code? Somebody shared his code in the chat. It's quite long actually. First occurrence and last occurrence of one. We can just calculate the distance between first and last occurrence. Yeah, somebody said that like for checking up this kind of a case, you can just find out the first and last occurrence of one, and then just check whether this is happening. Ki once is equal to two and first equal to last minus one. But there are other ways as well. There is one better way. Okay, so let's move on to the code. The code is pretty simple. For like you don't really have to worry about. Um, just don't get worried about what is this and what is this and what is this debug and what is this solve. You don't really have to worry about it. Just come up at it. Just look at the code inside this part. First of all, I'm taking the inputs. Then I'm calculating the number of ones. Ignore this line. After that, I'm checking if the number of ones. Okay, yeah. Here I'm checking if the number of ones is equal to 2 and the string has 1 1 coming up together. In that case, like this part is just checking if the substring 1 1 is present or not. In that case, the answer is no. Otherwise, the answer will depend upon whether ones is even or odd. So I hope the code is clear. And somebody is asking, why do you always use anonymous functions? Why do I always write a code in this way? So the reason is, um, like if I just go up at this place and write up, uh, create a function and then come up here and call it. In that case, I will have to navigate a lot. I will have to go up and down in the code a lot of times. And in the ABC problems, we generally have to write up the code as fast as possible. So I feel that anonymous functions are better. And one more advantage is, if I define a function globally, it can access only the variables which are defined globally above that function. Whereas, uh, and a function which is declared at this place can actually use everything which I declare at this place. So if I have to do some pre-computation in some problem, it would be a lot simpler for me. Okay, so let's go to the second problem. And by the way, somebody is saying that I should go a bit faster. So guys, what do you think? If you ask me, I can go up a bit faster. I don't really have any problem with it. Okay, a bit faster. Mostly people are saying this. Um, okay, like since mostly people are saying that go faster, some are saying it's fine. Okay, I will go up only a bit faster. I think that there is no majority here. Okay, so let's see the second problem. It says that there are n cows participating in a coding contest, coding tournament. Okay, great. There are n cows participating in a coding tournament. Cow I has a outforces rating of AI, which like all of the ratings are distinct. And initially, the ith cow is at the position I. The tournament consists of n minus one matches. The first match is between the cow in position one and the cow in position two. After that, each match I will be between the cows in positions I plus one and the match, like the winner of the previous match, that is I minus one. And in each match, the cow with the higher Codeforces rating wins and proceeds to the next match. We are the owner of the kth cow, and we don't really care about winning the tournament. All we care about is winning as many matches as possible. And as the like whatever it is, the problem says that we can swap our cow with some other cow exactly once, or sorry, at most once. It's up to us if we want to swap our cow with some other cow. Let me come up to the top. Okay, so let us say there are some cows. Cow number one, cow number one, two, three, four, five, six, seven. We will be given some cows, and each and every cow will have its code forces rating, or actually cowed forces rating to be more precise. Let me write it as 12, 10, 14, 11, 8, 3, and just get lost. Right now, our cow is actually which one? Yeah, our cow is this one. The problem tells us that what will in um, among these cows, a tournament will happen in such a way that the first two cows will play a game together. The one with the higher rating will win. The one with the lower rating will lose and will get out of the contest or the tournament. Then the next cow, which is this one, will play against, like this one will play against the previous winner. Here, this 14 is larger, so 14 will win among the in the game of these two. Then this 11 will fight with this 14. 14 will win and 11 will lose. Then 14 will defeat 8 and 3 as well. So the tournament will go in this way. And we have been told that what is like which one is our cow. What we want is like our goal is not to win the tournament. What we want is that we win as many games as possible. And we have been given one facility. We can swap the position of our cow with any position we want. So if you say that, hey, please swap your position, like swap the position of this cow with this cow, it can be done. This is allowed. And like that's it. What we want is to win as many games as possible. Maximum number of games which we can win. Max number of games which we can win. Okay, so is the problem clear? Okay, very well. Let me take one example here. Uh, let's take this example 7 to 7 to 7, 10, 12, 13. Here, our cow is this one. What we can do is swap this cow with any cow we want, or just don't make any swap, or just don't make any swaps. It's up to us. We can make at most one swap, and after that, the tournament will start. What we want is we should win the maximum number of games possible. So here, the very first observation I had, which looked really obvious to me, is even at this part. Let's say if your cow is coming up at this place, then these cows would have already participated in the tournament, and the one with the maximum code forces rating, would have won the tournament so far in these among these cows. So you would fight with the cow having the maximum rating here, which actually goes here as well. If you see, 7 and 2 will compete, 7 will win. Then 7 to 7 will compete, so 7 to 7 will win. Then 7 to 7 and 10 will compete, 7 to 7 will win. And now, when it would be your turn to uh, compete with somebody, you would be competing with the one having the maximum value in the prefix till now. So, if there is anybody who is greater than you on the prefix, can I say that you would just lose your first game itself? If there is anybody in this prefix who is greater than you, for any I, if any I is greater than AK, then you will lose your first game itself. So at the very least, it makes no sense, or I can say that it does make sense to swap your position with somebody who, like if you have anybody on the left side who is greater than you, then it makes sense to swap with them, right? So here it makes sense to swap with this way. Okay, this might also not be really intuitive here for you. That should you really just swap with this, or could there be a better alternative? One thing which is obvious is if you swap with anybody on the right hand side, above, like after it, then in that case the story will be the same. Before, like let's say you swap with this guy, then in this prefix 7 to 7 with the one who is dominating, so you will be like whenever it comes to be your turn, you would compete with the one having a greater value than you, so you will lose. So it makes complete sense that whatever position you go, you should have all the elements on the left hand side to be smaller than you. So whatever is the position k for you after making the swap, ai should always be smaller than ak for all I which are smaller than k. Otherwise, you will lose your first game itself. Now, the next question. Should I swap this 12 with this 2? Will it ever make sense to swap with the 2? Right now, it does make sense, but it might not make sense in all the cases. Let me take a simpler case actually. Let's say if you are having an array such as 1, 2, 3, 4, 10, 5, 6, and this 10 is your cow. This 10 is your cow. So, at what place should I shift this 10 so that you play the maximum number of games or actually win the maximum number of games? This is obvious that swapping this 10 with this guy or actually this guy as well, swapping it with one of these people will make the maximum, like will help you to play the maximum number of games. To keep things simple, let's say that you will always swap to the first guy. If like you will never swap to this guy or this guy or this guy or this guy, you will always consider swapping with this guy instead, right? If you are the largest guy in the array, right? Or even if there was some element here with some larger value, if you are swapping up with anybody on the left hand side, which is like you have a guy which is greater than you, if you're swapping with anybody on the left hand side of that person, then in that case it would be the first guy only. It will never ever make any sense to swap with anybody else. Can I say this thing? It should be obvious now. Like it should be obvious, because if you swap with this guy, then you will just end up playing one less game. है ना? You will eventually lose to the same person, whether you swap with this, remain at the same place, or swap with this or this or this. Eventually, you are gonna be losing to the same person to this. So it makes the more sense to swap at a place where you are at the first place. Now consider a case like 1 to 10, 3, 4, 7, something like this. And this 7 is your call. In that case, you know that swapping up with this, maybe here it does make sense, but if it was something like 1, 2, 3, 4, 5, 6, 7, 8, and 9 was your call, then swapping up with like you know that swapping up with anybody of these will never make sense because you will just lose your first game itself. Swapping up with this four, like 5, 4, 3, 2, or 1, at the end of the day you will lose to the same person, that is 10. So you should consider only swapping up with this guy, swapping your core with this guy, or like for these people it makes no sense, for these people it make no sense, but what about swapping up with this 10? Will it make sense to swap with this 10? I think it will, because if you swap up with this 10, 10 will come up here and 9 will come up here. So like you will play up with this 6, 7, 8, and the winner of the previous games, that is 5, that is 1, 2, 3, 4. You will defeat 4 people and then will lose to 10. So um, you got two candidates which might have some significance for all the other people. You all like know that it will never make any sense. Since there are only two people, what you can do is just swap up your position with the first guy, swap with the first guy, where whatever value of k was. In case if you're coding, you would most likely have zero based indexing. So just swap with like 0 comma k if you're having zero based indexing. After that, check the cost, like just find out the number of games you are able to win. Just check the number of games you can win. check the number of games you can win. Yeah, if you want, you can write k minus one. But like when I'm saying talking about zero-based indexing, I'm expecting that you would have already subtracted k by like you would have already decremented k at the time of taking inputs. You know, like you should never take up input and wait. Whenever I will use it, I will use it as minus k minus one. Just subtract it at the same time so that you don't make any error later on. Right. Okay. Just come up here. Swap your cow with the zeroth cow. Check the number of games you can win. Then swap that. Then swap 0 comma k once again. So basically you got your cow at the first place. It is like you never swapped with the zeroth cow. Then check what will be the number of games you can win if you swap with the first element which is greater than you. So find the first I such that a of I is greater than a of k, and then repeat the exact same steps here like this. Just swap with that cow, check it out, and then swap back, and whatever, like it will give you some answer, and here from here also you will get some answer. The maximum one of them should be our answer. I hope that this thing makes sense. Now let me read the chat once, and uh, you can grasp this thing till that much time. Okay, the problem is clear. It's just the prefix max problem. Swap with first try and greatest try. Yeah, that's what we did there. Depends upon right elements. Swap with max. Swap with this. I made a really long logic for this question. It took me like 20 minutes. Actually, you're talking about 20 minutes. Just go up and open my profile and you will see how big of a blunder I did. Like my brain was just not working during the contest and I really played very well, very, very bad. Are we discussing D? Yeah, we will discuss D. We will discuss D after the C problem. Makes sense. I don't want use false flags. I use so many false flags. Okay. I got frustrated today. I made six wrong errors. Okay. Looks like nobody's having any doubts regarding this. What is the rating of this problem? I think it should be something like 11, 1200, something like that. Okay, so shall we move on to the code part? Wes, just please spam code if you want me to go to the code. Just spam code in the chat. I thought answer is max number lesser than max left and right. I don't know. Okay, so many people want code. Let's go to the code. Okay, so here also, like the previous time, you don't really have to worry about most of the stuff. Just worry about the content written inside this solve function. This is like, if you see it, it is a way of creating functions. Um, the syntax might look a bit different, but this is just a normal function which I'm creating, and then I've been calling that function for every test case. At the starting, I'm taking up all the inputs, and since I want zero-based indexing, I've been reducing k almost instantly. Then what I did is I initialized answer with zero. I am first of all swapping the cow which is at the position k right now with the cow at the position zero, and then I have been calling the check function uh, and I have been storing that value inside answer. Though a better thing would have been done that these swap valley lines could have been actually included inside the function itself. But anyways, it's also fine. And after that, I have been going on inside a for loop to find out the first cow which is greater than the which is having a greater rating than you, and swap with that cow and then find the answer. Now see one thing, I'm checking up only till the cow k, because it will never make any sense to swap your cow with some other cow on the right hand side which is greater than you, because it will also result in answer getting zero. Like this is kind of obvious thing. And the way in which we have been finding out the number of games you can win is just pure brute force. It actually, I believe that this thing can be done in big of one, but um, I just did not want to take any risk of getting small errors from here. So I wrote a brute force. It is fairly simple to do. And at the end, I'm just printing answer. Okay, so let me see the chat. function के अंदर yeah, function this is a function inside which this is a function inside this inside which this is a function, and sometimes what happen is inside that we might again have a function. This sometimes happen. This is problem B, not problem A. Can you explain significance of AI greater than AK again? See the thing. See the thing is, we noticed wherever our cow is, like if there is any cow on the left which is great, having a greater value than you, then what will happen is, um, the cows coming up before you will play against each other, and at the end of the day, the cow having the largest value would be winning. So your first match would be again, which like would be against this cow, which is a sure shot defeat. You will just lose in your first battle itself, and you will have no profit, no benefit, right? So to avoid that, like you know that this cow should be coming up before this 10. है ना? This is obvious. So swapping up with this, any of these will never make any sense. Secondly, we just saw that if you swap up with this guy, you will play against like this. You will play against more number of cows in comparison to swapping up your cow with this cow. In that case, you will play with less number of cows. So we got the idea that it will also never make any sense to swap with any one of these. Now for the cow which is coming up, like the first occurrence of any cow which is greater than you, in that case swapping up with this cow can make up a lot of sense, because if you swap up with this cow, then this 10 will come up here and this 9 will come up here, so you will get to um, play against some number of cows. So this one might give you the answer. You can actually try to create a test case, something like 1, 2, 10, 3, 4, 5, 6, 7, 8, where 8 is your cow. Then in that case, swapping up with this will give you a lot of benefit. है ना? Okay, you got it. Great. Somebody is asking that how could we do this thing in big of one? So the idea is we are just counting the number of cows in the like. See, if you have swapped up with this cow, you already know about the you already know about the index from where you have swapped the cow. You know about this index, so you know that all the cows which will come up in between, that is, um, if this is I and sorry, this is k and this is I, then k minus I minus 1 will be these cows and this cow. In case if this is not the first guy, then you will get a plus 1. Yeah, this will be the number of cows you will defeat. But I just did not want to take any risk. My brain was not really working well at that time. I could not focus well at the start of the contest, so I did avoid it. आराम से भाई रुक जा, move to C. Okay, okay, let's move on to C then. Um, when we swap AI AK, why are not we checking for the previous elements that might also be lesser? That might also be lesser. See, all the people who are lesser than you, you know that one of them will win among these people and you will fight with him, you will defeat him. Since you know that this is the very first guy who is greater than you already know that there will be no person on the left hand side which is greater than you. Baki, if you want, let's say you did not notice this observation at that time, then you could have actually written up a for loop for these people as well. That just find out the maximum of all of these people on the left hand side. You could have done this. Okay, you got it really well, really good. But can we add previous element as well into the answer? We are talking about this, Rana. We will actually add this. Yeah, we will actually add this. If you see, like in my code, I have considered it that if I'm not the first guy of the array, if there is anybody on the left hand side, then I would get to compete with him as well. And I know that everybody on the left is smaller than me, so I would be able to defeat him. So answer will be incremented here. Yeah. Baki, it's not really that complicated. You can just write up a complete for loop from the start till that point wherever you want. It's a fairly simple thing. Just brute forcing this function is fairly simple. The main idea was talking about uh, like just pruning the search space. We did not really know initially that with which cow can I swap, but I intelligently removed a lot of options from my site and was left up with only some options which I could brute force. Okay, so let's see the third problem then. Um, this is the third problem, ticket hoarding. The problem says that as the CEO of a startup company, you want to reward each of your key employees with a ticket to the upcoming concert, and the tickets can be, uh, tickets will be on sale for N days and some time traveling. Huh? You can. Okay. And by some time traveling, you have predicted that the price per ticket at day I will be AI. However, print to prevent ticket hoarding, the concert what concert organizers have implemented the following measures. A person may purchase no more than M tickets per day. A person purchases If a person purchases X tickets on day I, all the subsequent days, that is from I plus one onwards, will have their tickets prices per ticket incremented by X. And then they have given some example, and then they have been asking that find the minimum spending to purchase K tickets. Now the actually okay. Now the actual PCD begins. Great. Okay, so let me tell you about the problem here once again. I think the problem statement in the way in which I read the problem statement might be really vague. What it says is you have been given an array A where um, AI tells about the price of ticket on the ith day. Price on ith day. So if you see three written on three written on the third place, it means that on the third day the price is three, and so on for everybody. The thing is, since they wanted to um, like let's leave the story, just talk about the constraints. On any day there will be a limit, like you will be given an integer m which tells that on any day you cannot buy more than m number of tickets. So if m is equal to 2, then you cannot say here I will buy 5 tickets at the price of 3. It uh, prohibits you from doing that. So you will be able to buy only 2 tickets. Let's say 3 into 2, you got a cost of 6 and you bought 2 tickets. Then all the prices of tickets after that day, let us say on some other day the price was 7. Since you bought 2 tickets here, the price will be incremented by 2. Let's have some okay, let's just understand the problem statement first. Okay, so I think that till this part it should be clear. Now the thing is, we have been given some integer k, which tells us that this is the number of tickets we want to buy, and we want to find out the minimum cost for buying k number of tickets if we buy optimally. Or basically, you just want to find out the minimum cost to buy these k tickets. Let's say if k is equal to 3, then since I have not really written the complete array, I can't really show it here. Let me take up an example test case. 8642. 8642, and m is equal to 2 here and k is equal to 3 here. You can buy at most 2 tickets on any day, and you want to buy 3 number of tickets in total. So like since we are just having the example right in front of us, we can manually check that it will never make any sense to buy up these tickets, since like we are not really talking about the logic part right now, just looking at the problem manually, you should be probably will be able to identify that the best thing we can do is buy two tickets on these on this day and buy one ticket on this day. So the price will be 4 plus 8. On this day, the price would have become 3. So 3 into 2, that will come up to be 10. 4 plus 6 coming up to be 10. Right. Like I've not really discussed any logic part here. I'm just showing you. See, when I read the problem, I went to the test case and I was able to see what we will have to do. So the basic idea which I had at this point of time is the cost of the ticket on the ith day. Let me call it as AI, or maybe I call it as cost, or whatever I say. Let's call it as AI for now, or maybe let's call it as cost I for now. The cost for the ticket on the ith day will be equal to AI, which is the the initial array which is being given to me. That is the base price. Initially, the price for the ticket on every day. And since it is gonna be incremented by the number of tickets I have already bought so far, so it will have some inflation depending upon the number of tickets I have bought so far. Depending upon the number of tickets I have bought so far. Right. And this AI does not depend upon anything. This is constant. It has been given to me in the problem once and it will remain constant. It won't be changed. Right. And I want the total cost to be minimized. Right. Since I want the total cost to be minimized, this is something I would like to minimize. Like I would like to buy the tickets on those days where AI is as small as possible. And let's look at this inflation, whether we can do something with it or it is out of our control. So let us consider this kind of a case. What if the tickets were having a price 11111 and M was equal to 1, let's say. Then what will happen is when you buy the ticket on this day, all the people will have their costs incremented by 2. Or I can say that would have got the inflation amount being become equal to 1. Then when I it does not really matter where I which one which day I choose. Whichever day I choose, the value of this inflation will remain the same. Let me put up my laptop on charging. The basic idea which I had at this point of time is this inflation does not depend upon which day I choose. It only depends upon the number of tickets I have already bought so far. So the total cost for these days would have now been 2. Like this row is the AI. This is the inflation. Let me move it here. Yeah. This is the inflation. And this guy is the total cost so far for every day. Huh. Now it does not depend upon which day I buy. Let's say I buy the ticket on this day. Then the inflation for all the other people would be incremented. It will become 222 everywhere. And the total cost will become 333. Right. So can I say, like for this kind of a case where M was equal to 1, my answer at the end would be equal to the summation of all the AI where if I'm buying a ticket on the ith day, um, basically all the days where I'm buying the ticket and the inflation I've got so far, total inflation I would have got so far. And in the case where M is equal to 1, whenever you will buy the first ticket, the inflation at that day would be 0. Whenever you buy the next ticket, you would have got an inflation of 1. Whenever you buy the next ticket, you would have got an inflation of 2. Whenever you buy the next ticket, you would have got the inflation to be 3 by that time. It would go on till n minus 1. So sum of first n elements is n minus 1 into n by 2, or you can just say it as n into n minus 1 2, n into n minus 1 by 2. And this is something you would just like to minimize. There are ways for this. Like you would have already been getting the idea of. We will like we will look at it. I won't really leave this part for you. I won't actually show you how to do. First of all, tell me that does it look intuitive? Does this thing look intuitive? Intuitive. Now, can I say that if I had been given an array like 1, 2, 3, 4, 5, 3 coming up here again, and k was equal to 4 and m was equal to 1, does it look intuitive that on any day you can buy only one ticket, and when you buy that ticket the cost for everybody afterwards would be incremented by 1? So since you want to buy up 4 tickets, prove that the order of elements does not matter. Yeah, that I'm just coming up at that part. I've not proved it yet. I'm coming up to that part. Right now, I'm just trying to develop some intuition for it. So, since we have actually got the intuition of that this inflation part does not really depend upon um, which day I was buying the ticket. It was only depending upon the number of tickets I've already bought so far. So, if for this kind of a situation, I buy one ticket at this place, one ticket at this place, one ticket at this place, and one ticket at this place, then what will be the cost I would have got? For this guy, the cost would be 1. For this guy, the cost is 2, 3, 3, but they have some inflation as well. This guy had inflation as 0, 1, 2, 3. So the total cost, like let's call it as base cost, and this will be the inflation. The total cost we have got so far is actually equal to 15. That is the sum of all of these. And I can call it as the sum of these 4 people, which is 9, plus the costs of all these inflations, which is coming up to be 6, right? And this is actually not really depending upon which days I chose or in which order I chose those days. Just imagine if the array, this exact same array, was actually written in this way: 4, 5, 3, 1, 3, 2, or maybe you can have any other permutation also. You could still buy the cost, like the tickets on these days, 3, 1, 3, 2. The inflations would still be in the way 0, 1, 2, 3. It does not really matter. Like you just see that the inflations are still the same. It does not really matter in which order these elements were. At the very least, we have been getting this kind of an intuition. You know that if you just leave this part of inflation, in that case, it does not matter in which order the elements are. You can just sort the array, and like you will just sort the array and find out the answer, because you will have to find out the sum of k smallest elements in the array, right? Since you want to minimize, this sum of ai, you would like to find out this value. And the other part of inflation is not really depending upon which days you chose, right? Now there is one thing: if m is not equal to 1, in that case, will there be some difference, or would everything remain the same? Let's take the simplest example once again. If there are a lot of ones, and let's say m is equal to 2 here, if you buy a one ticket on this day, let's say if you buy one ticket on this day, you would get a cost of 1 with inflation 0, and you buy a ticket on the next day, then you will get the cost 1 with inflation 1. So the total cost will come up to be 3. Whereas if you had bought the other ticket as well on the first day itself, then the inflation at that day would be 0, right? The inflation on that day would have been 0. So the total cost would have been equal to 2. Does it look intuitive? Guys, by the way, guys, how many of you are with me right now? We have not really talked about a concrete approach. We are just talking about some easy observations to see, like the observations which you could see. We have not connected the dots yet. We will form an approach. Okay, somebody is saying we are with you, but what about others? Mostly people have not replied anything. In case if you got lost somewhere, then please mention it. Maybe I can give a small recap here so that you would be able to keep up with me. And in case if it is fine, since like your motive should not be to just understand what I'm speaking, you should mostly focus on looking at the ideas I'm trying to figure out, basically the intuitions. Now I did not observe the order does not matter, very given partial sum. Yeah, it is gonna be very given partial sum. Okay, if it's fine, then let's continue. Okay, so we got the idea that it is better it is better to buy like multiple tickets on the same day, because if you buy a ticket on this day and then a ticket on some other day, then you will have some inflation on the future days. Whereas if you're buying a ticket on the same day, then you will not have that inflation. You might have a doubt here that can it at any day be better to buy up a ticket on this day and this day instead of buying up both the tickets on this day? These are like the comparison is simple. If you're talking about two different days, let's say A5 and A10, you have to buy, let's say, two tickets and you're confused whether I should buy up two tickets on this day, zero on this, or zero tickets on this day and two tickets on this day, or just buy one ticket on both of these days. See, if you buy two tickets on this day, then in that case, for these two tickets, the cost will be 2 into A5. Whatever other inflation you are getting from because of some other guy would still be there, but right now we are talking only about these two tickets. If you buy two tickets on the day A10, on the day 10, basically having the cost A10 at that time, then the cost would come up to be 2 into A10. But if you buy the tickets one on A5 and one on A10, then you will have a cost of A5 plus A10 plus 1. You would have got another inflation of 1. And um, this would have been there in the other cases also. Like here also, you would have got an inflation for the A10 of 2, but since you were not buying on that date, it did not affect. Here the thing is A5 plus A10 plus 1. This is definitely gonna be larger than at least one of these. Like if you look at the better answer of both of these, it would come up to be 2 into minimum of A5 and A10. You know, one of these will actually have this cost, which is definitely better than this cost. So can I just say it would always be better for me to buy as many tickets as possible on the same day, because in that case I would save I would save some inflation cost on these tickets which I'm buying on the exact same day. Right. It is looking up to be intuitive. So as of now, we have not really developed any approach. We have only talked about some intuitions which we have got so far. Yeah. So let me just have a very small recap for all of this once again. At the very start, we first of all understood the problem. Like till this point, we just understood the problem. Then we looked up at a sample test case. We did not really discuss about any approach. We just looked at it and try to do some sort of hit and trial, basically just using some common sense to solve it in a normal way. After that, we did like try to break down the component of the cost into two parts. One of them is the constant part, which would remain the same, and the other part which will change. And we just saw that the inflation does not really depend upon this I. It does not really depend on which day I am at. It only depends upon the number of tickets I would have bought so far. है ना? And eventually, like if you see, w- like whichever days you choose, I will buy the tickets on these days. At the end of the day, inflation is something you can just say ki it is equal to. Maybe I should not make it more complicated uh, by creating an expression here. But in a nutshell, you have already got an idea ki that inflation part is something I can calculate separately, and this AI part is something I can calculate separately. This inflation part, if k was equal to 1, in fact, like in a nutshell, this inflation part has no dependency upon this I. It does not really depend on which day you bought. This blue marker will have its contribution exactly the same, in the exactly same way. Then we did discuss about the part that since the inflation is something which is not depending upon AI, can you independently find out the minimum possible value for this summation of AI with on like whichever days you choose? So we just um, try to look a bit at it and try to just have a permutation 1 2 3 instead of having 1 2 3 3 we are having 3 1 3 2 just to get the idea, just for confirmation that the order in which elements have been given does not really matter because the sum of these people, like the sum of these AIs, will remain the same. And these inflations does not even depend upon which elements I chose. It only depends upon um, like if m is equal to 1, it does not even depend upon anything. Like we just saw that if m is equal to 1, then the answer is the inflation cost would be constant eventually. But if m is not equal to 1, it does depend upon the fact whether you bought one ticket today, two tickets today, zero tickets today, or how many tickets, right? It does depend upon that thing. We just saw this thing right now. So the idea we have got so far is to reduce AI, it makes a lot of sense to buy tickets to reduce the summation of AI. Buy tickets when AI is small. Since order of elements does not really matter here, I have not proved it. I have not proved it yet, but I think that it is not hard to prove. I'm just not proving it because it will make the PCD larger if like longer if I prove it here. But it is not hard to do it. The thing we have discussed so far is if you want to reduce AI, buy tickets when AI is small. So we can just sort the array A and then start traversing the array from the beginning. The second thing is to reduce inflation, summation of inflation, try to buy more tickets on the same day. Try to buy M tickets on a day, which will actually make sense. Like if K is greater than equal to M, in that case, buy M tickets. Otherwise, just buy K tickets. Basically, the remaining number of tickets, remaining number of tickets. And this part of buying multiple tickets on the same day actually makes sense because since you want this AI to be as small as possible, you would like to buy more number of tickets on the smaller price, and that is reducing inflation as well. So you are getting both the things done in the same way. Let me take an example. If you have this kind of an array 8642, sorting the array as 2468 and then traversing from left to right, since you have to buy three number of tickets and like on a day you can buy at most two number of tickets, it will make up a lot of sense to buy up both the tickets on the same day so that The contribution of the base price of the tickets, that is AI, is as small as possible. It is just coming up to be 2 and 2. And the inflation you had is right now 0 for both of them. Once you would have bought them, the inflation would now become equal to 2 for the tickets in the future. That is nothing but the number of tickets you have bought so far. After that, you are having 4 as the smallest possible cost for you. So you will buy the ticket uh, on the cost of 4. By the way, K was initially 3, you bought 2 tickets, so K would now become equal to 1. Since K is smaller than M, you will just buy 1 ticket here, and the inflation would have been 2. So the answer is coming up to be 2 plus 2 plus 4, that is 8, and 0 plus 0 plus 2, that is coming up to be 2. So you're having 8 plus 2 equal to 10 here as the final cost. Um, so we just try to dry run the approach, which is working on the example test case. Similarly, you can dry run it on the other test cases also. Wait, we choose two tickets of this number. Okay, so guys, is everything clear so far? Akhilesh, is your doubt also clear? Like the doubt which you asked a few minutes ago? Okay, great. So shall we move on to the code part? Okay, cool. So first of all, I'm taking up the inputs. Ignore this DBG. After that, I have been sorting the array. I kept track of the number of tickets I have bought so far and the answer I have got so far. I think that here we can have some overflows. The constraints are, I think, huge enough. Yeah, the value of AI is huge. So summation of AIs can result in overflows. In my case, I have actually defined int as long long so that I won't have to worry about that. And uh, in the for loop, I have been going up, but since I have already sorted the array, the elements which will come up earlier in the for loop will have smaller values of AI. So it is beneficial for me to buy as many tickets as I can. The number of tickets I have not bought so far, K minus bought, it will tell me the number of tickets I want to buy more. And M is the number of tickets I can buy on a single day. So MN will be the maximum number of tickets I can buy today, or the maximum number of tickets I should buy today. The cost I will have for buying these MN tickets would be equal to MN into AI plus bot. That is basically, I've just written both the costs together. AI was the base cost and bot is the cost because of inflation. Ignore this DBG again. Answer has been incremented by cost and bot plus equal to MN. Basically, since we have bought this many tickets, so I'm incrementing the value of bot as well. And at the end, I'm printing answer. Okay, so guys, is it clear? Shall we move on to the next problem? Somebody said that he got a WA on the pretest too. We spent 40 minutes trying to find the flaw and then changing some of the ints to long long past the solution. Okay, this is quite tragic. Um, like when you're not sure during the contest, this is something you can always prefer. That just write up define int long long. Uh, by the way, during practice, I highly suggest to remove this line unless you have to use long long everywhere. During practice, it is good to write it at the places manually so that it is in your practice. But during contest, you can prefer to write up this line so that you don't have to worry about it at any place. What if I choose, what if I choose to not buy until we get the smallest number, but does not this affect the cost at which we buy the ticket initially? Okay, so somebody is worried. Are you worried about the fact that what if I was having 2468 and 8642? Like, are you willing to ask that buying the ticket at this thing, like in this kind of a scenario, it will cost me only um, 4 rupees. And these tickets will cost me 3, which is 3 plus 3, that is 6 rupees. Whereas in this case, it will cost me only 2 rupees, and this will cost me 4 plus basically 6 rupees since the value has been implemented. Is that your doubt? Okay, this is your doubt. See, the thing is, this 4 was nothing but 4 plus 0. This 3 was 2 plus 1. And this 3 was also 2 plus 1. Right. Whatever we have been getting as the answer in the sorted array, this is 2 plus 0. This is 2 plus 0. This is 4 plus 2. Basically, the base price plus the inflation, base price plus inflation, and so on. So, the base prices in the original array would have been same, like in whichever way you buy the tickets in this array, since this element which is coming up here as 2 would have been coming up at some place in the original array. This 4 would also be coming up in some original array. So you believe in one thing at the very least, that this sum of costs would remain the same. This thing, the sum of these 2 to 4 and 4 to 2 would definitely remain the same, right? This is something you believe at the very least, right? है ना? The AI we have here should be equal to the AI we have here because AI never changed. But the inflation did change. In this case, when I bought a ticket on on this day, it increased the cost of 2 tickets by 1. In the other case, the exact opposite happened. I bought these 2 tickets which increased the cost for this ticket by 2. See, this is what is happening. And it will be there for all the comparisons you make. Let's say you had bought some tickets on these days also. You would have compared that the increase in cost because of this guy, the increase in cost of this ticket because of this guy will be the exact same as the increase in the cost of the tickets you buy on this day because of this guy. Like if you buy a ticket on this day, then the increase in cost will be 2 here. Similarly, if you buy 2 tickets here, then the cost will increase in cost will be 2 here. So at the end of the day, it will just be the same thing coming up here and there, right? And like there is one thing which I had not showed here. I thought that it might look a bit overcomplicated here, but if you had tried to think of a formula for inflation, you would have, like if you try to create a formula for inflation, or maybe let's leave it. It's not a high rated problem. We don't really need to overcomplicate things because I'm not really sure how complicated it might become. Because let's say, just imagine that I mess up and make it overcomplicated, then it's better. Like I will show it after the session, maybe. Shall we move on to the next problem for now? लेवल से ऊपर है, टाइम लगेगा प्रोसेस होने में. Um, okay, okay, it's fine. Like PCD is not for spoon feeding completely. You should just focus on mainly getting the idea so that you can try the problem on your own after the PCD. That was the main idea, right? Okay, so for now, let's look at the D problem. The D problem is kind of observational. So, like the explanation might be a bit smaller for this. And obviously, like I think that if you're coming up for this problem, you are probably at least a specialist, most probably. The problem says that, let me just write up the problem here. You can read the problem statement if you want. Since I'm having some pain in my throat, I'm gonna um, try to wrap it up a little bit quickly. Let's say, sorry, I had never had this thing. See, Bob is having a jewelry store. Bob is having a store of his own. Bob is a big man. He's a rich guy. And Elise is a customer here. Elise is a customer having n rupees. This is the money she has. Like, ठीक है. Elise is having some money. Bob will have some stalls in the store. Let's say that this is the store of Bob. Bob store. It has a big board, Bob store, whatever. And Elise enter from here. There will be some stalls which Elise will go through. Every stall will have unlimited amount of jewelry with some cost. Let's say the price for the first stall is P1. Like all the items available on the first stall are having the cost P1. Then the second stall has the cost P2, P3, P4, P5, and so on. And Bob knows that Alice is really greedy. When she comes up to this stall, she will buy as many items as she can, unless, like, let's say if Alice is having 10 rupees and the cost of P1 is 3, then in that case, Alice can buy 3 jewelries. So she will buy 3 or jewelries or item, whatever it is. Alice will buy 3 items and then she will have 1 rupee left. Then she will go to the next stall and buy as many items as she can. Let's say the price on second stall was equal to 2. Then in that case, you see that Alice cannot buy anything. So Alice will still have 1 rupee remaining and she will go to the next stall. There, let's say that P3 is equal to 4. Again, Alice cannot buy anything. So she will go to the next stall. Let's say P4 is equal to 1. So Alice will buy this guy. She can buy only one item. So she would get 4 number of total items bought so far and n will become equal to 0. Um, no, it's not always gonna be possible to get all the jewelries. Okay, so as of now, is the problem clear? Like, not the problem, but the order in which Alice buys the jewelries, is it clear? And actually, Bob knows about it. Bob knows about the secret. So he would like to place the stalls in such a way that, as Bob already knows about the money which Alice will have, he wants to place the Bobs in stalls in such a way that Alice will eventually buy K items only. Bob knows about it. And this is the goal, that Alice should be able to buy exactly K items. No more than K, no less than K. So is the problem clear? Okay. Okay, great. So let me just take some example from the sample test cases. Let's say if, let us say if n is equal to 7 and k is equal to 3, you want to place some stalls. You can place at most 60 stalls. There is a limit that you can place at most 60 stalls. You have to place those stalls in such a way that allies should buy exactly k equal to 3, like this many items. And there is one more thing which they have mentioned, that it is not necessary that allies spend all her coins. It would be fine even if allies is left up with some coins at the end. It is fine even in that case. So one way of doing it is, let's say P1 is equal to 2 and you don't even need other stalls in that case. What will happen is allies will come up to this place. She will buy 3 items, spend 6 coins. So number of items will become equal to 3 and the remaining number of coins she had would remain, like, would become now 1. And since there are no more stalls, she won't be able to buy up anything. Right. This is one way. They have given one very weird way. Uh, Obviously, they cannot just give the solution directly. So they have given a very weird solution here. And similarly, there is another test case having 255 coins and she wants to buy 8 items. So they have given something like 128, 64, 32, 16. They have actually given the explanation here that how she would end up buying 8 jewels only, exactly 8 jewels. But this K can be really huge. So, like this, I don't think that this pattern will ever have any significance, or at the very least, this is not really that controllable for us. A better idea which I had in my mind is like I got this idea instantly when I just looked at the problem for n equal to 7 and k equal to 3, something like this. I just got the idea that what if I say the cost is 5 initially or something like this? Like I just say a number. For the stall 1, I just have P1. And for stall 2, I have P2 equal to 1. If I have something like this, and I make sure that Alice buys only one item here, and she should be left up with K minus items at the end. I had got this kind of an intuition that Alice is initially having an equal to 7 points. But if I try to place some place the price in such a way that allies buy only one item and then she should be left up with k minus 1 coins, since the price would be here equal to 1. She would buy k minus 1 coins here, and eventually she would have got k coins, sorry, k items in total. This was the intuition I got, and then I tried to think about it. um, all I have to think about is this part, that what price should I pick up for this guy. And this is quite simple. What I want is k minus 1 should be the remainder from n. So n minus k minus 1, something like this. Sorry, n minus k minus 1. If I pick up p1 to be something like this, then n mod p1 would, I guess, turn out to be k minus 1. Like, I think it will happen. I did not really try to create these equations. I just did it with hit and trial. I thought of n equal to 10, k equal to 3. Since I want 2 be to, 2 should be the remainder at the end. So P1 was coming up to be 8. P2 was P2 was 2, obviously. And similarly, I tried out some other cases like n equal to 7, k equal to 3. In that case, I want 2 to be the remainder. So picking up 5 as the first guy is good. Like P1 equal to 5 makes sense here. If I wanted k equal to 4, in that case, I would have wanted t to be the remainder. So P1 equal to 4 would have made sense. So basically, P1 was coming up to be n minus k minus 1. Now there is one thing. Like since they had mentioned, there is a test case where we are failing, the test 6-4. At this case, we have been failing. So I just tried to think about it that um, I just tried to think about it. K n equal to 6, k equal to 4. According to that sample test case, there is no way of having some stalls. So here, one thing which I noticed, which is coming up to be really intuitive for me, is that here my k is actually greater than n by 2. So I was having some idea, like I was having some doubt that does it have anything to do with it? If n is greater than k by 2, then do something or something else. Does it have anything to do with it? So you can just try to look up at this part. P1 is equal to n minus k minus 1. If this if this P1 turns out to be smaller than k minus 1 or even equal to k minus 1, for some k being really huge, like P1 might come up to be smaller than equal to k minus 1. In that case, if you choose this P1 as the price 1, actually what will happen is allies will buy more than one item because the remainder, basically n minus k minus 1 is actually greater than equal to p1. So allies will buy more than one item of this cost. So as like if you try to think about it, you will realize ki, it is never possible for any k being greater than n by 2, or actually n plus, maybe you can just say it as n by 2 upper C. It is never possible for any one of these to have any way of um, giving. Basically, there is no way of having stalls in any way such that you are able to get this many items. Is it possible to set up every case listen? We explain Kardo. Okay, so let me revise once again. Let me just revise it once again. There was a store having a lot of stalls. Like these stalls are up to us how many stalls we want and what should be the prices. Allies will come. Allies will come here and she will buy as many items as she can buy on the stall one. Then she will buy as many items as she can buy on the stall two. Then on stall three, stall four, and so on. And we can decide the prices by our own choice. One intuition which I had was that, let's say if I take P2 equal to 1 and I take P1 in such a way that on the stall 1, Alice will buy one item and then she will have K minus 1 coins left, so that she will buy K minus 1 items. Right. We did try to think, like we did come up with an expression that P1 should be equal to N minus K minus 1. If this is the case, in that case, K minus 1 will come up to be the remainder. We can cross verify this thing for some test cases, that what if n is equal to 10 and k is equal to 2 and so on. Like just try to think about such test cases. Now, since we know that we will have some wrong answer, like they have, sorry, no answer as no, they have given it as the hint. So we just try to think about this case, that what is the problem in our approach for this? Like what will happen in our approach when n is equal to 6 and k is equal to 4? N equal to 6 and k equal to 4. P1 will come up to be 3. N minus k minus 3, k minus 1, which is coming up to be 3. So what will happen is, allies will actually buy, instead of plus 1, she will buy plus 2, and she will not have any points left. So the whole basis of our approach, which was this thing, has failed. Right. For this case, the whole basis of our approach for deciding the value of P1 is actually failing. So here I try to think that is it ever possible if yeah, by the way, one more thing. I did try to do dry run for some more cases. Like what if n is 7, 9, 11? Basically, n is odd. Till which value of k can I easily get the answer? Uh, I had tried out these cases also, and there I came up with the conclusion that if k is less than or equal to n plus 1 by 2 upper C, basically something like n equal to 9 and k equal to 9 by 2 seal division, which is coming up to be 5. Till this point, if k is smaller than or equal to this, it is simple for me. Till this point, I can just simply say ki, by the way, let me check one thing. Yeah, k is at least 1 here. In case of k could have been 0, then we would have to have some more edge cases. But right now, k is definitely gonna be greater than 1. Right now, see, for n equal to 9 and k equal to 5, I found that till this point my approach was working. I just did some hidden trial for, basically did some dry run to check till which point my code is, like logic is working. P1 comes out to be P1 minus N1 plus K minus 1, which is 5. So on the stall one, you will buy only one item and then you will have four coins left. So you will buy four items on the next K and next time, and you will end up with having five items. So our logic is working till this point. If k is equal to n, this is an edge case. This is a really simple thing. Just have one stall with price equal to 1. This is damn simple. You will end up buying n number of items. So this is another thing. Now for the case where k is greater than n by 2 seal division and less than n. For all these cases, what we want to see is there some way to get this many items or no? The test cases is giving us some hint that we might have answered no in those cases. So the thing is, since I want more than n by 2 seal division, more than that many um, items, let's say if n is equal to 9 and price of the first uh, the price of the first stall is 2. In that case, I will actually be able to get only 4 items and like only 1 rupee would be left. So I will be able to get up till n by 2 seal division, only this many items in this way. But if I had taken 3 here, it would have got even worse. Things would have actually become even worse in that case. For 4, 5, 6, 7, I just tried out a few of them and realized that it is never coming up to be more than n by 2 CL division. So random hit and trial was hinting me that if my k is in this range, then my answer should be no. Like random hit and trial was hinting me this part. And just for the proof, for a logical proof which would satisfy me, I just checked out that hey, if I put up p1 equal to 1, in that case I will just get n items on the very first stall, right? Which is greater than k, which is greater than k here. So you don't want it. We will have p1 to be something smaller, and for all of them, let's say even if you have something like 2, you will get only n by 2 floor division and then maybe plus 1 maximum. Uh, the thing is you can never have the remainder being you can never have the remainder being greater than k minus 1 thing to be coming up. You can never have this thing in this scenario. We have already seen it that it is not possible. Like the reason is simple. If you just pick up p1 equal to n minus k minus 1, and here k minus 1 is greater than or equal to this p1, in that case you will buy more than one. Like Alice would have bought more than one items on the first stall. So as a conclusion, when you try to think about it a bit on your own, you would realize that hey, if I take up p1 equal to 2, I'm still able to reach only till this amount. And if I put up something bigger or anything, I would never be able to have. Um, Actually, this is not really a formal proof, I guess. This is just some hit and trial stuff only. Yeah. Okay. So what I did is not really a proof here. What I did is a hit and trial thing. So I checked out for P1 equal to 2, 3, 4, just for formality, and for anything greater than n by 2, like P1 being, if you see P1 is smaller than equal to n by 2, in that case, you will never have the remainder being greater than equal to n by 2. And if you have P1 being greater than or equal to seal division of n by 2, in these cases, also you will not have the remainder greater than equal to n by 2. So I was basically not getting my answer in both the extreme cases. In the extreme cases and random cases, I did not get get anyway. So okay, looks like my approach is not really a concrete proof. It is just some randomization, which satisfied me that if my k is equal to n, My answer is simply just one stall with P1 equal to 1. If my answer is less than, if K is less than equal to N by 2 seal division, then also my answer is simply P1 equal to N minus K minus 1 and P2 equal to 1. And for the remaining case, for the else case, till this point, I got satisfied that I'm never getting the answer, so I will just print now. And I tried to submit it, it did work. We can see that max answer possible is anonymous true, that is, so it will decrease halfway. Yeah, but like this is not the this is not the concrete proof. This is just some observations we have made. Can I set first stall as N by K and increase the remaining store price? You can try, like you can try the idea I've been getting. Eventually, as much as I know, you will also get the exact same idea, exact same result. And obviously, the solution has passed the test cases, so it's correct. Um, I think I won't know what is. Okay, so any more doubts? I think it's like anything is between them is not possible between n and n by 2. Yeah, exactly. Anything between them is not possible because this is the maximum k I am able to reach other than this one. Yeah, D is greedy. Actually, if you look at E, it is also sort of greedy, kind of greedy. Like I don't know why is my code failing on the E problem. I got WA on test case 9. So probably my approach is correct. I would have just missed one or probably one or two edge cases, or maybe I did some implementation error at some place which I could not find during the contest. But right now I have no motivation of solving it today. Okay. I have done using NVK and if I show my this, can you tell why is it not working? Yeah, I can have a look at it after the session. For now, guys, please tell me whether we should move on to the code or not. Like, if you want me to discuss the code now, just spam code in the chat. Okay, code. Great. So the code is fairly simple. I just took n and k as input. Did have a sorry, a base case here that if n is equal to k, just print yes and only one stall with price one. Otherwise, if k is greater than n plus 1 by 2, which is nothing but the CL division of n by 2, in that case, print no. Otherwise, print yes. The number of ones and like the P1, I have just calculated them and I have just printed them. This is an assert condition just for checking that in case if my like in case if this condition returns false, then my code will instead of giving a wrong error, wrong answer, it will give me a runtime error so that I will know here my code has must have failed at this place. If you don't know about assert, you can just skip this part. It's not really that important. So that's all for this code. Now for now, I'm stopping the recording. And for the ones who have been watching the video on YouTube, you can please consider liking the video or subscribing to the channel. Thank you for watching the video. Please give your feedbacks in the comment section. I would be really happy to read them.